First of all, I'm Francesco. Nice to see you all. We are about to speak about Retrieval Augmented Generation. We'll start from basic toys, going towards to enterprise RAG. But first things first, let's see what is RAG. So RAG stands for Retrieval Augmented Generation. So 3 steps here, but actually we are already missing one, the ingestion step, which is, of course, crucial for the subsequent ones. We are leveraging 2 powerful generative AI techniques. The generation step and the retrieval step. The retrieval step is not exactly generative AI because it can leverage different techniques, not specifically embedding models, but also more traditional information retrieval techniques. But the generation step, it uses a generative model, a language model, and it tries to generate answers based on the retrieved data, and if it's appropriate, even leveraging its own knowledge. So in essence, we first query some sort of retriever with a user with some kind of input, which can be the user input, a user message, but can also be a more complex thing. Think about Codebases. We try to find relevant documents, and then we pass all these retrieved documents to the second step. So the retrieved information is combined with a language model to generate a coherent and hopefully correct answer. Of course, this has to be balanced with the large language model problem of hallucinations. So at some point, we'll start thinking about it now, but at some point we will need to add some checker, some fact checker chain at the end of our generation step. A sample prompt, large language models are being programmed with standard programming because we need to involve LangChain, Llama Index, or the HTTP REST API, but at some point we might need to write some code. But they are also programmed through prompting. And this is how very basic RAG prompt looks like. So you are an enterprise assistant, answer the question based only, and that only matters, on the following context, if it is helpful. And we are passing the context here. We are bounding the context. Then, if you don't know the answer, just say that you don't know. Don't try to make it up an answer. This is a very naive approach to reduce the number of hallucinations. Of course, it doesn't work. Not at scale. You don't answer general question or out of the scope questions, and you must not be repetitive. But this is combined before being passed to the model. This is combined with the question, in this case it's a question, coming from the user. And here we also have one more piece. So the chat history. This will be relevant in a couple of minutes. As I said, in this prompt here, there are a few things to be noticed. The first one is that we use the word only. So answer question based only on the following context. This is strictly dependent on the business context you are dealing with. There are, based on our experience, there are a lot of use cases in which that word only can be removed, and actually it's better if it's removed because there are general questions and it makes sense that the system answers also to general questions. One more relatively important piece is the fact that the context is bounded and well separated from the rest of the textual prompt. This helps the model to figure out where it has to look for information. So, how is the context retrieved? There are several ways. The most famous in these days is for sure embeddings. So we have a vector store. A vector store is a database, essentially a database, and also standard relational and no relational databases are supporting embeddings. So it's a database with a lot of numbers within it, embeddings. And when we search for a document, we are going to find the most similar numbers to the original number. So the user query is transformed to a huge list of numbers, the embedding of the user query, and that list is matched with a similarity metric with the documents stored on the database. But this is not the only possible approach. But first of all, there are also more complex databases like graph databases that can implement both embedding and structured documents, but also more, as I said before, more standard information retrieval techniques like term frequency, inverse document frequency, standard keyword-based algorithms, and also external black box API. For a project I'm working in these days, we are simply using Google APIs, I mean a custom engine built from Google APIs, and we use that as a black box, no need for embedding, no need for nothing, because the most important part there is the reasoning step after the retrieval. So we don't care much about the retrieval, it's public information, public available, but we care about the next step. So we delegate the entire retrieval step to a black box API. Given this introduction, we are now going to see a demo toy, and then we are going toward the enterprise RAG. So we are going to cover all the tricks to apply on the different steps of a proper enterprise RAG pipeline. And we'll also cover some of the techniques beyond the standard RAG, enterprise RAG pipeline, like agentic pattern, graph RAG, but also multimodal RAG and structured RAG. So this is how a few lines of code. This is how a demo, a conference demo of a RAG pipeline would look like. So we are loading a PDF, as simple as that. We are splitting the PDF into chunks. Now, let's focus on this. We are splitting the entire PDF into chunks. Given the most recent models, this is not really needed unless you have more than 500 pages of documents. But if you have a small documents, you can also pass the entire document, so no need for a proper RAG pipeline. You just pass the entire document, so you just load the document and pass the entire document to the prompt I showed you before, and ask the model to give you the answer to the original question. But considering normal enterprise use cases in which you, of course, have more than 500 pages of documents, this is needed. So we split the document. In this case, we have a chunk size of 1,000 tokens, and we have 200 tokens of a window overlap between different chunks. We are storing those chunks into a chroma in-memory vector store. We are using OpenAI embeddings to embed those documents, so we are transforming those chunks into numbers. Then we are building, this is done with LangChain, but with semantic kernel or Llama index, it would be the very same story. We are transforming the vector store into a proper retriever. We are getting a prompt. This prompt here is exactly the one I've showed you before. And we are defining a function to format documents just to fill up the context variable we have seen in the prompt. And then here's the magic. So the context variable is filled with calling the retriever, then formatting documents, and that's all. This is the context variable. The question comes directly from here. We are filling the prompt. What does it mean? We are just replacing the variables. In that case, we had two variables. In the prompt I've showed you before, we had two variables. So I'll show you it again. Here, we have two variables, context and question here. So we just have to fill those two variables. And here, we are filling context and question. We are passing it to the prompt, compiling the prompt, calling the large language model, and then applying just an output parser. This is needed just because we are using a chat model, but we want the answer to be just a plain string and not a message containing role and content. At the end, we just invoke the chain passing the external input it has to receive, so use a question. This is the magic happening for the question variable. Runnable pass-through just takes these and passes it to the next step. So, very cool, but the question is it really working in a real-world scenario? The answer is, of course, otherwise I wouldn't be here. The answer is, of course, no. Why? Well, first of all, what if, this is the most basic point. What if the question is a follow-up question? Even considering the original prompt and putting the history inside the prompt, the entire prompt, if I am asking a follow-up question, what am I passing to the retriever? Am I passing just the user question? Because if I'm talking about, I don't know, financial reports, I ask for, what was the number of employees from Microsoft last year? It gives me a number, and then I ask, what about 10 years ago? If I pass this question, what about 10 years ago to the retriever, it cannot give me any interesting result, because the question itself, it doesn't mean anything. It means something just in the context of the conversation. So we should condense the entire conversation and the last message into one standalone, self-contained question we can query against the vector store. What if the user is, it can happen, somehow misleading? Are we going to ask clarifications? Is the model going to ask clarification to the user with respect to the question? It should, as a human would do. If someone asks me something and I don't understand, I just ask for clarifications before going through the entire cycle. What if the documents are complex? What if documents require a reasoning step? What if the user, the final user, needs citations? Verbatim citations. And then what if someone is asking for meta questions? The easier example of a meta question is, how many questions did I ask you until now? I mean, it would go, given the toy we built before, it would go directly to the vector store. But searching for what? I mean, it wouldn't find anything relevant with this question on the vector store. Let me remind you something and stress something. Here, the retriever is called with the only external variable, and the external variable is just, in this case, it's just the user question. So if I ask the system, how many questions have I asked until now, it would pick the user question and go to the retriever with that user question. It makes no sense, of course. And this leads to the agentic pattern we'll explore in a second. But even more simpler point, what if the documents are just more than text? I mean, images, tables can be converted into text, but there's an interesting paper from Microsoft a couple of weeks ago. They published a paper about how to handle embeddings of tables. It's not that easy, but can be managed. But also structured data. Until now, we've just seen an example with a PDF, but there's more than that. There is a whole world made of structured or semi-structured data. So what can we do? We can implement some mitigation strategies at each step of the chain, so ingestion, retrieval, augmentation, and generation. With respect to the ingestion mitigation, first of all, the first tentative to do is trying to find a better chunking strategy. In my opinion, I mean, recursive, token-based or character-based splitting, they don't really work in a real-world scenario. But semantic chunking is a sort of working solution, not the best possible, but quite cheap with respect to the agentic chunking. What does it mean? Semantic chunking doesn't split the text based on the number of tokens. It just split the text based on the similarity between different sentences and paragraphs. So it doesn't stop at the middle of a sentence or even at the middle of a paragraph if the next sentence is connected semantically speaking, and it measures the semantically similarity with the embeddings. It just splits when the similarity is under a threshold value of similarity. So if the document is talking about something, then it changes the topic, it will definitely split. Of course, this is based on embeddings, so it's not perfect. We should define a threshold value. We could use standard ones based on percentiles, but it's usually something that you must try, and it's strictly dependent on your document base. Agentic chunking, so this has a cost in terms of embeddings, but embeddings are quite cheap. I mean, it depends on the number of documents you have, but usually it's cheap. Agentic chunking, it's a whole different story, because we are involving an LLM, usually a smaller one, because we don't want to pay a lot of money for chunking, and trying to leveraging the recent upgrades from OpenAI and Anthropic, leveraging the prompt caching feature. So we are asking a separate, smaller, and cheaper model to segment, to chunk the original big document. Anthropic released, it was September, and they released a white paper talking about this. They called it contextual retrieval. Essentially, they were using an agentic chunking, but they didn't just chunk the original text. They asked the model not just to separate sentences and words and paragraphs, but also to add to each chunk the context. Like the example they made on this white paper was, if I am reviewing financial statements from company, I will use Microsoft as an example as usual. We are talking about Microsoft, and I have a sentence at the end of the document saying, okay, this year, the turnover, this sales growth by 300%. Okay, but with respect to what? So the contextual approach they used passed the entire document to a small model, asking to chunking and to adding the missing contextual information to each chunk. So this final chunk using this approach would look like Microsoft last year had, 20 billions of sales for Azure. This year, sales growth by 300%. So each chunk is self-contained and auto-explanatory, so that when we retrieve the chunk, we have all the needed information. And agentic chunking and contextual chunking is definitely an advanced technique, but even simpler approaches can work very well, like FAQ, so frequent asked question generation on the knowledge base. Why? Because usually documents are written in an assertive way. They have an assertive form. But questions, user interaction usually comes in an interrogative form. So we must match the differences, because otherwise the embedding or even the keyword searching might silently fail. So generating questions based on the document helps to reduce the gap in terms of semantic of questions and documents written in an interrogative and assertive form. Generation of summaries also is helpful. And in case of semi-structured data, also metadata generation helps a lot. Think about documents that have some authors, that have some data, some dates, that have some keywords, some sensitivity, standard metadata for a textual document. We can leverage those metadata to filter the query and to filter the documents passed to the final answer generation step. One more approach that works pretty well, and it's kind of general, it's the multi-vector retrieval. So we embed something, usually a smaller specific chunk, but then we retrieve a larger chunk to give context. This is the cheaper version of the agentic chunking before. So agentic chunking on huge data sets can be very, very expensive. We can mitigate these using a multi-vector retrieval. So we embed small pieces of text so that the similarity search would work definitely better, but we give the model a bigger chunk with more context. It's not perfect. Of course, if the relevant context is at the beginning of the document and the chunk I'm interested in it's the end, this approach will not work, but it will cover a lot of cases in between. Then when it comes to the retrieval step, we have anticipated this before. So condensing the original user query into one standalone question is something that must be done always. I mean, no way, how naive, how small is the application, this must be done. Unless you have just one single query with no more interaction. So the user just queries for something and then it can't do anything else. In that case, no need for this, of course. And the prompt to do that would look like something, given the following conversation and a follow-up question, just rephrase the follow-up question to be just one standalone question. But as we said before, user questions can be in a very different form from what we would be expecting. So we might need to do some rewarding on the user inputs. The first simplest approach is just a simple rewarding. So asking a model, here we are involving again, so it's becoming more expensive. We are asking again a smaller model to generate a few variations of the original query. But we can also involve more complex approach. One is a step-back question, so it tries to generalize the original question and goes to the retriever asking for different questions, starting from the user's question, going to a more general question, or sub-questions, which is least to most, it's exactly the opposite. Or hide. Hide stands for hypothetical document embeddings. This is a bit tricky, but it's a great idea. So, we have a question coming from the user. We are asking a model to generate with no knowledge of our document base, nothing. Just asking a model, please give me an answer, generate me a document that answers to this question. We don't care if the answer generated by this smaller model is accurate or not. Of course, it will not be accurate. It won't work because we are building this entire system exactly because general knowledge of ChatGPT, Claude, whatever, it doesn't work enough well for our code base, for our document base. But we are asking just, please give me a document answering this question. Why? Because the document that the model will generate will look like a correct answer. So we will embed the generated fake document to query the vector store, trying to search for real documents that should answer the same question because they would look like the same. Of course, the content, it should be different, but the form, the words used should be similar. So we are creating a fake document answering our question, and we are passing the fake document to the retrieval step, looking for similar existing real documents. I know it can sound a bit weird and counterintuitive, but I swear it works. It works pretty well. Beyond that, there is a problem. Even with huge context windows of new models, there's still a problem called lost in the middle problem. So we have to reorder documents by importance, giving the less important documents space only in the middle of the context. So most relevant documents should be on top and at the end of the context window. As we anticipated before in last slide, metadata filtering is an option when you involved at the ingestion step metadata generation, or if you have already, because your document base is already built with metadata, if you already have metadata. This brings us to a structured querying chain, which is pretty different from the textual querying part, but there are a lot of tools, built-in tools in LangChain and Llama Index to do that. So they basically create a JSON query, and they execute that JSON query in a raw form over the vector store, filtering for the metadata. This is not perfect. I mean, especially when metadata structure is complex and rich, it is essentially a text to SQL or text to whatever approach, which is not perfect, which doesn't work always well. But it's for sure, it's worth to try, to give it a try. Then beyond that, of course, why just one retriever? So we could have more retrievers, one for Google, so external knowledge, one based on standard information retrieval techniques like BM25, one with vector stores, one with a structured database, and so on. Worst case, we will need to fine-tune the model, or the textual model to generate the proper query, or fine-tune the embedding models to generate more accurate embeddings based on our documents. And if this is not enough, then the last try is a neural database. So essentially, a neural network built from scratch just to associate, to match user query to existing documents. Honestly, until now, I haven't seen a single case in which a neural database was really needed. But I mean, there could be this chance. Or GraphRag, but we'll cover GraphRag shortly. Regarding the augmentation step, what we usually do is just giving an explicit reference, an explicit code ID to the document and passing it to the context for the generation step. Why? Because in this way, if the user needs citations, it knows exactly what snippet it has to quote. So we're just, I don't know if you remember, but I've showed you a function before. It was called format document. It would just put the entire text, separating it with a new line character. In this case, we are building a more structured context. So we are including ID, title, and the physical snippet of the source document. This is proactive to the generation step, because in this case, all we want to do is extract citations from the answer. So we define a function and leverage the function calling capabilities of a model. What does it mean? It means that we define the answer not just to be plain text, but it has to be answer, which is a string, and the description is the answer to user question, which is based only on the given sources. And also, so the final answer that the model has to produce contains a string representation of the answer, but also a list of citations. And each citation has a source ID and the verbatim quote of the original snippet. So we should know exactly why the model gave us that specific answer, on which very, very exact pieces the answer is taken from. From the code perspective, it can look like this, or easier with LangChain like this. So LLM dot with structured, passing the output we want to have in terms of, in this case, of a pedantic schema. What happens under the hood is that we're leveraging the function calling capabilities. So the model has been trained, fine-tuned actually, to call functions. But in this case, we are using a trick. We are not really having a function to call. We are just defining a function, and this function has as an input parameters answer and citations. So the model has been trained to call external functions. We define a fake function that does nothing, but has those two parameters, those two input parameters. So the model knows that it has to call that function, and it will extract those two parameters from the function calling. Then, of course, we are not calling any function because no function really exists. It's just a trick. And LangChain and Llama Index, they have just hidden all this dirtiness between these syntax here, so with structured output. But the real, what's happening under the hood, it's these. So we are adding a tool to the large language model, and we are saying, please call this specific function, and then we are using a JSON parser to extract from the fake function calling the model has done to extract the needed parameters. There's no real need to understand deeply this step here unless you have some very specific scenarios. You can just use the more simple syntax and skip the function calling fashion syntax. So at the end of the story, an enterprise RAG could look like these. So I missed a few steps on purpose, like input guardrail and output guardrail, and the observability pipeline, because what an input guardrail does and an output guardrail does more or less the same. It's just checking if the input question is allowed with respect to some business rules. A concrete example, we work in Italy with Vatican Hospital, and we built a chatbot for them. It's more or less a clinical chatbot. I mean, we can't say it's clinical because otherwise the AI Act or whatever. So it's not a clinical chatbot, but it's like a clinical chatbot. But there are questions that cannot be answered. And the input guardrails just helps filtering those out. While the output guardrail, well, it is usually more than an output guardrail, but it should be more a checker, so a fact checker. In fact, going beyond the enterprise RAG approach, we should involve something like these. So and this is the output guardrail part. So this is a real-world flow in which we have the retrieval step. We reorder documents. Remember, lost in the middle problem. We reorder documents. We are asking, are these documents relevant to answering the original question? Here, a new model, so more cost to come. If the answer is yes, then we pass to the generation step. If the answer is no, we try to rewrite the question and come back here, the retrieval step. This is built with LangGraph, so it's a graph, it's a state machine. After the generation step, it arrives the output guardrail step. So we are checking if the generated answer is containing hallucinations or not. Of course, if the answer is yes, we will come back at the generate step, with some feedback for the model, so like adding a sentence, please stick to the given context, don't make up an answer, please, please, please. Prompt begging helps in this case. But if the answer doesn't contain hallucinations, we have to do one more check. So is the generated answer really answering the original question? If the answer is yes, then we will give the answer to the user. Of course, if the answer is no, we'll start it from the beginning. And until now, we have talked about the so-called text-to-embedding RAG. But as I anticipated before, there is something beyond that. With text-to-embedding, we embed textual information, and we retrieve them at the retrieval step. But this works for local information. There are questions that cannot be answered in this way. So there are global questions that need to be considered in a completely different way. That's why graph RAG comes into play. So it has to solve this global need. The ingestion step here is completely different. So we involve an LLM, or in case it's a code base, we could use the compiler tools like Roslyn for C#. So we have to build a knowledge graph from the knowledge base. Involving an LLM for extracting the knowledge graph requires for sure multi-turn extraction and entity and duplicates removal. Then once the original, the basic knowledge graph is built, we have to group together similar nodes. And using the edges between nodes, we have to build a summary for each community. So we group together highly linked nodes, we build a community, and we write down with an LLM, so it's expensive, we write down a summary for each community. What's the problem with this approach? That when we are adding a new document is expensive and complex. Expensive because we potentially need to update all community reports, because a single document could be linked to every single community we have generated. But it's complex because we must extract relationships accordingly to the existing schema, because we already have in place a graph built from the original document base. But we have to stay open. At the same time, we have to stay open to catch new entities and relationships. So this balance is complex, even for a human. So when do we need to add new entities? It's not an easy problem, and it's strictly dependent of the use case and the business rules. And at the query time, we have to route our question. So we have to understand if the question is local, then we apply the canonical approach. If the question is more global, we have to apply a MapReduce approach, generating an answer based on each community report that is linked to the user question. I say MapReduce approach because community reports, usually when extracting a knowledge graph, we are talking about hundreds of thousands of entities. So definitely a big number of community reports. So a MapReduce approach is usually needed. So we give the model the original question, we give the model one by one in a MapReduce fashion each community report to build a final context-aware, global context-aware answer. In some cases, we might need to implement an hybrid approach. So we might need to retrieve similar chunk similar with respect to the question, to the user question, similar chunk, and related entities, so nodes and edges, based on the knowledge graph. One concrete example of this approach here is when you're dealing with code. So for a client, we built a system to write down test cases based on a completely undocumented code base. And in this case, we leveraged the compiler tools. So we built a knowledge graph based on the compiler tools. And then we had a multi-agent approach. So we had several LLMs asking questions, one to the other, asking questions on the code base. And to answer those questions, we have an hybrid approach. So we retrieve similar code chunks, but also give the contextual information of what is calling that specific code chunk. So it's called in this class here, it's referenced in this library here, it's used in this view here, and so on. So the final piece generating the test cases has all possible knowledge. So similar chunks, and they catch the architectural patterns from similar chunks, but also a global overview of where that specific piece of code is used and how it's used across the entire code base. A few more tips and I'm done. Real-world tips. Give more tools to the agent, such as access to Wikipedia or Google or so on. If privacy is key in your use case, then you should anonymize the question and the context before passing it to the final model for the answer generation. We usually do that with Microsoft Presidio, but also Skyflow Data Vault is great at that. Handling multimodal documents. So this can be done in two different ways. One is using multimodal embedding for ingestion, and then using a multimodal LLM, and every LLM nowadays is multimodal, for answering, or using multimodal LLMs to generate textual description. So we do a textual embedding, and then we retrieve the image based on the textual embedding and use a multimodal LLM for answering. Why these can be needed with respect to these, which seems a more obvious strategy, because multimodal embeddings, they don't really work perfectly. The most famous is Clip from OpenAI, but text embedding large, and I mean, the new embedding models, textual embedding models, they work better than Clip. So sometimes this approach here works even better than the multimodal embeddings approach. Finally, taking care of semi-structured and structured data. So at some point, you might need to involve some chain for text to SQL, or, and this is very new, the paper was out 1 month ago, Table Augmented Generation. This is a relatively new approach, very cool, and works great with structured data. It essentially involves a semantic layer on top of the database engine, so that questions like, so that it can translate on the database engine even semantic operations like join one table and another table based on a similarity metric. So like I have a table for courses and a table for skills, and I ask to give me all the courses that can be helpful to give me some help with a specific skill. This is done by joining the courses table with the skills table based only on the semantic value of the skill. So essentially, to make the join, I'm asking, is this skill useful for I mean, is this course useful to learn this skill? If the answer is yes, then we'll build on database level the join. It doesn't work. For now, it works only on a Python environment, but they are building also a SQL adapter. That's basically all for me.